So in this video, we're going to discuss a very important concept in physics, which is called work. And work is defined as equal to force times the distance moved in the direction of the force. In the direction of the force. I'm going to emphasize this, of the force. In the direction of the force. This is very, 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 very important. I'm going to highlight this part here. In the direction of the force, right? So work is just equal to force times distance moved in the direction of that force that is doing the work, right? So when an engine pulls a train with a constant force of 50 newtons through a distance of 20 newtons, its work is just going to be equal to 1000 units. It will be equal to 1000 units. We just say the force is 50 units times a distance of 20 units. So we just get 1000 units, right? Work is a scalar quantity. It is a scalar quantity. Doesn't have any direction. So when, by definition, work is, by convention, work is measured in things called joules. So the joules are, we define it as 1 joule is the work done by a force of 1 newton acting over a distance of 1 meter in its direction. This part here, where it's moving in its direction of the force, is very, very important. So that's how you define a joule of work. This work is also a measure of energy transferred. It's also a measure of energy transferred to the object by this force. So let's look at why I emphasized. So imagine you are pulling a boulder here with a force of P. The boulder is not, this is the ground. The boulder is not flying off the ground. The boulder is going in this direction, right? I think we can all agree. When you're pulling something, it stays on the ground, but your force is in this direction. Let's say at an angle of theta. So I highlighted this to say in the direction of the force, because this object is going to move through this distance here. Let's call this distance S. The horizontal distance that is going to move is going to be S. So which force is working for it to move in that horizontal direction? It is not P. It is a component of P. There is a component of P. Let's break down P into two components. We have the vertical component. We're going to have the vertical component of P, and we are going to have a horizontal component of P, right? The vertical component of P is going to be P sine theta, and the horizontal component is going to be P cos theta, right? Does the component P sine theta do any work on this object? No. Look at the direction for P sine theta. It's upward. It's upward. But our object is moving a distance of S on in the horizontal direction. P sine theta is vertical. There is no work there. They're at 90 degrees. They don't affect each other at all. So P sine theta is actually wasted. This is when it comes to this, to work on this object. P sine theta has nothing to do with the work being done here on this object. Nothing. But P cos theta is in the horizontal direction, the direction that this object is moving in. So the component that is actually doing work is P cos theta. So work done on that object is equal to P cos theta times S. P cos theta times S. So that is the work done on this object. And that's why I had to emphasize that if you're doing work, it is force times distance moved in the direction of the force. Or you can say distance moved by the force that is in the direction of the distance. In the direction of the distance. That's what we did here. What is the direction of the distance? Horizontal. So what force should we consider? It is a force that is in that same direction of the distance that has been moved, which is the component of P, which is P cos theta. P sine theta was not in that direction. It was actually a perpendicular direction, which means no contribution whatsoever from P sine theta. So that is a very, very important point. You're going to see this even in your tests or your exams, it's a very, very important concept that work is done. The direction has to be, the force has to be in the same direction as the distance that is being moved. So that is an important concept there. In the next video, we're going to quickly discuss another important concept, which is called power.